GPAT 2017 questions on basic level from organic chemistry. So let us start with the first question. In a free radical reaction, free radicals are formed at options are A. Initiation step, B. Propagation step, C. Termination step, and D. Both A and B. So here the right answer is both A and B. That is both in the initiation step as well as in the propagation step. Halogenation of alkanes is one type of a free radical mechanism. This involves three steps, and step 1 is the chain initiation step. So in the chain initiation step, the halogen undergoes homolysis to give the halogen free radicals. This step is initiated by either thermal or photoenergy. And second step is the chain propagation step, where what are the halogen free radical formed in the step 1 reacts with the alkane. Now the alkane is attacked by the halogen free radical and it forms the alkyl free radical plus hydrogen halide. Now here the alkyl free radical which is formed again then attacks on the halogen, thereby it produces halogen free radical plus alkyl halide. In this way, alkane can be converted to alkyl halide, where in this step the halogen free radical is regenerated. So this regenerated halogen free radical again attacks one more molecule of alkane so that the chain is going to be propagated continuously. Step 3 is the chain termination step. So this is a step where all the free radicals are consumed to produce the molecules. For example, an alkyl free radical combined with another alkyl free radical to give an RR, a higher alkane. Otherwise, a halogen free radical combined with another halogen free radical to give the halogen. Otherwise, an alkyl free radical can combine with a halogen free radical to give the alkyl halide. So in the chain termination step, any of these two free radicals are combined to give a molecule. Now you can see that free radicals are formed in the two steps. Step 1, that is the chain initiation step, and step 2, chain propagation step. And these are the two steps where free radicals are generated. So the right answer for this question is the chain initiation step and chain propagation step, where the free radicals are generated. And in the step 3, the free radicals are actually consumed. Let us see the next question. Reduction of imines to give amines in protic solvents can be carried out by one of the following reagents. Select the correct reagent. First one is sodium hydride. Second one is the sodium chloride and HCl. And third one is the lithium aluminum chloride. And fourth one is sodium cyanoborohydride. So here the right answer is the sodium cyanoborohydride. So reduction of imines is one of the procedure where the imine is converted to amine. Imines can act like Schiff's base, which are produced because of the condensation reaction between a carbonyl group and an amine, and which can be again reduced to give a further higher amine. Suppose this is the imine. Now this imine can be reduced to amine by using one of the reagent NaBH3Cn, that is a sodium cyanoborohydride, which is the reagent which is selectively reduce the imine to the amine. Sodium borohydride can also be used, but one of the problem with the sodium borohydride is that it can reduce the imine as well as it can reduce the aldehydes and ketones. So it is not selective for the imines, whereas sodium cyanoborohydride is selectively reduce the imine to the amine. Let us go for the next question. Which of the following cannot react as a nucleophile? Options are CH3,4N+, CH3NH2, CH3 twice NH, and CH3 thrice N. And here we can observe that All the options are given are one is a primary amine, secondary amine, tertiary amine, and quaternary ammonium compound. Now the right answer is the quaternary ammonium compound. So option A. Nucleophile. Nucleophile is indicated by Nu. What are the characters of the nucleophile? So it should have some characters like it should have a negative charge so that it can attract the positive charge. Otherwise, it can have the lone pair of electrons. Any of these characters should be there for a nucleophile. Since quaternary ammonium salts are not having negative charge, instead they are having positive charge, and they are not having lone pair of electrons, where the lone pair of electrons of the nitrogen are again taken by the one more alkyl group, so they cannot act as the nucleophile. Which of the following reagents will reduce a disubstituted alkyne to the trans-alkene? Options are sodium and ammonia, and lithium aluminum hydride, and diborane, and finally palladium and hydrogen. So here the right option is the sodium and ammonia. Reduction of alkynes can proceed with the two reagents to produce a stereoselective products. For example, if we take an alkyne, this can be converted into cis-alkene by using the one of the reagent palladium plus calcium carbonate in presence of hydrogen and lead acetate and quinoline. So this is called as Lindlar catalyst, which converts the alkyne into the cis-alkene. So Lindlar catalyst will undergo syn addition, that is the groups are added on the same side, so it produces a cis-alkene. Now the alkyne can also be converted into trans-alkene by using the other reagent, that is the sodium or lithium used in presence of the ammonia. Now this reagent can produce an anti-addition where the groups are attached on the opposite side of the alkene to produce a trans-alkene. So in the given question, what are the reagent used in the production of trans-alkene is the sodium plus ammonia. Which functional group is present in the molecule shown below? So options are amide, alcohol, ester, and ether. So this is a very simple question, and we can observe the functional group is the cyclic ether. So ether is the right answer for this question. A fatty acid not synthesized in the human body and has to be supplied in the diet is. So options are stearic acid, oleic acid, palmitic acid, and linolenic acid. So the right answer is the linolenic acid. Linoleic acid and linolenic acid are called as essential fatty acids. They are not synthesized within the body, so they should be supplied in the diet. So this is the structure of the linoleic acid. So we can start the numbering from the carboxylic acid 1, and we can give the numbering such that the double bond is present at the 9th position and then the double bond is present at the 12th position. Now this is an fatty acid with 18 carbons with 2 double bonds. So this is the linoleic acid. And another one is the linolenic acid. Again in the linolenic acid we can give the numbering from the carboxylic acid, and then double bond is present in the 9th position, in the double bond at the 12th position, and we can observe one more double bond at the 15th position. So this is an 18 carbon chain having the 3 double bonds, so this is called as linolenic acid. So both linoleic acid and linolenic acid are the essential fatty acids.